Hi there, my name is Allison Moore, and this summer I worked with Roshni Koshnik and Dr. Reed Simmons in the Reliable Systems Autonomous Lab to develop a set of facial expressions for Corey using ROS and Gazebo. Assistive robots that help people through their social presence and interactions rather than just physical components have become increasingly common in recent years, from children's toys to home assistants to help in medical or teaching scenarios. The rise of robots that interact in a social capacity raises the question of how we can create technology that communicates in a way that is both effective and likable, as both of these components are important in comprehensive social interaction. Depending on what social context a robot is expected to act in, we might seek out different facial expressions or communication methods. This summer, I specifically looked at establishing effective and likable communication with Corey, a robot designed specifically for human-robot interaction. While Corey has a wide range of applications, this work looked at using Corey in an educational context in the future. While this project is still in its early stages, this context informed my design choices when thinking about the best way to communicate using Corey. Corey has a broad potential for ways to interact, including body language, voice, and facial expressions. My focus this summer was specifically interested in developing facial expressions using Corey's backlit, retro-projected screen. In the future, we hope to combine these expressions with body language cues and natural language processing cues being developed in conjunction with this project. This project centers on the question, how can we generate facial expressions for Corey that are both easy to understand and easy to control? My goal this summer was to create a system that was both easy for operators and easy for users on the receiving end to use. When considering the understandable object aspect of this work, I looked at prior research on how people comprehend emotion and facial expressions. Since we didn't have time this summer to do an independent study on this, I primarily relied on prior research about the facial acting coding system, or FACS, which identifies distinct muscles and movements in the face separated by quantities called action units. This allows for quantization of every facial feature and emotion. In addition, I investigated the difference between people's perception of static and dynamically displayed emotions. For the most part, dynamic emotions seem to produce faster and better understanding, leading me to seek out moving facial expressions when designing the face of Corey. In my initial work, I created a series of still images to test what expressions and what facial features work for Corey. In this, I focused on being able to later map these images to dynamic features, and also focused on creating a face that was approachable and understandable without being too realistic to avoid the uncanny valley effect. In the control aspect of my project, I tried to develop a system process that allowed for a lot of flexibility and customization without being too complicated for users to understand. In my current iteration of this, I use a base processing function to map facial features and motion paths from a JSON file into OpenCV and ROS. This allows users to precisely specify what image positions and rotations they want for each facial feature without having to write any code. For example, on the left here, I have a snippet of a JSON file where the user specifies images and locations for one eyelid. The locations are mapped onto Corey and can be changed in terms of scale factor, rotation, size, and position. Using this method, we can create thousands of custom facial expressions and emotions. We are also not limited to the facial features I developed this summer, as these can be replaced with any image file specified in the JSON format. In addition, these features position, rotation, size, and animation rate can be individually controlled. This work is part of a larger project developing teachable robots for a peer tutoring context. This is still in its early stages, but going forward, we hope to link these facial expressions to body language cues and natural language processing. In addition, specific to this project, there is likely future work on auto-generation of features like eyes or the mouth between stills instead of relying on hand-drawn animation, testing of the understandability of Corey's emotions, and expanding the library of facial features and expressions. I feel so lucky to have had the chance to do this research and participate in RISS this summer. Thank you to the National Science Foundation for funding this research, as well as Roshni Koshnik and Dr. Simmons for helping me throughout this project. And thank you for listening.